Today I'm going to do an example of a question that asks you to find the equation of a tangent line given some function at a certain point. The first thing when you get one of these questions is to notice that tangent line, whenever you see the word tangent, you think first derivative. So in our case, we have a rational function. So we have a rational function in the form of f at x equals some function g at x over h at x. And for us to find the derivative of this function, we use the quotient rule. Now the quotient rule is the derivative of the first function, so the top one, times the function in the denominator minus the function in the numerator times the derivative of the function in the denominator, and all of that over the denominator squared, which is h at x squared. So we need to do this to find the derivative of this function. Well, what usually helps me out is to kind of stay organized. So g at x I know is 8x squared minus 3, my numerator. So g prime at x, the derivative of g at x, is 16x. And same thing with my denominator. So my denominator I defined as h at x, and that equals x squared plus 4. So the derivative of h at x, so that's h prime at x, equals 2x. So once I have all this information here, I can just substitute it into my equation for the quotient law. So I'm going to do that. So I know that f prime at x equals the derivative of the first, which is just 16x, times the second, which is x squared plus 4, minus the equation in the numerator, which is 8x squared minus 3 times the derivative of the denominator, which is just 2x. And that's all going to be over the denominator squared, which is x plus 2, or x squared plus 4 squared. Okay, so let's clean up my numerator here. So I can distribute my 16x throughout the bracket there. So I'm going to have 16x cubed plus 16x times 4 is 64x, minus, same thing with this side here. We're going to take the 2x and distribute it through that bracket there. So 2x times 8x squared is 16x cubed, minus 3 times 2x is just 6x. And I always keep that in brackets because of this minus sign here. A lot of times people will forget to distribute that negative throughout that last bracket, and that's a big mistake. And then we're going to keep the denominator the way it is. So let's clean that up. So we have 16x cubed plus 64x minus 16x cubed minus, negative 1 times negative 6x gives me the positive 6x. And then my denominator again just stays the same. So I have x squared plus 4 squared. Well, what tends to happen when you're doing the quotient rule is that your highest degree will cancel out. So I have 16x cubed minus 16x cubed, so I just cross that out. Now I can collect my like terms. So 64x plus 6x is 70x over x squared plus 4 squared. Okay, so that's the derivative of my function here. Now, initially my question was asking me to find the equation of the tangent line to the graph of this function at the point where x equals negative 1. Well, now that I've found my derivative, I can now plug in x equals negative 1 to find the slope at that point. So we're going to sub in -1 into my derivative. -1 squared plus 4 squared equals -70 over -1 squared is just 1, plus 4 is 5, and then 5 squared is 25. So when we simplify that, we're going to have -14 over 5. So I know that at the point on my tangent line of -1, this is going to be my slope here. So let's work up here. So let's think of a tangent line. Well, let's recall the equation of a line. It's just y equals mx plus b. The -14 over 5 that we just found by substituting -1 into our derivative is our m value, is our slope. So we're going to plug that in. -1x plus b. Sorry, -14 over 5x. I don't have an eraser on me, so -14 over 5x. Actually, I'll just rewrite that. Y equals -14 over 5x plus b. So now I need to sub in a point. Well, my point needs to come from my original function here, f at x. So I'm going to sub in x equals -1 into this function here to find a y coordinate. So I could sub it into my equation of my line, my tangent line. So f at 1 equals 8 times 1 squared minus 3, sorry, times -1 squared minus 3, all divided by -1 squared plus 4. So -1 squared is just 1. 1 times 8 is 8. Minus 3 equals -1 squared is 1, plus 4 is 5. So 5. Oh, sorry, it's just 1. Okay. So now I could sub that point, 1, 1, or -1, 1, into my equation for my tangent line. So we're going to sub in 1 in for y, and -1 in for x. And we need to do this to find our b value. Well, -14 over 5 times -1 is just going to be 14 over 5. Plus b. To solve for b, I need to bring this 14 over 5 over to this side here. So we're going to have 1 minus 14 over 5 equals b. Well, let's just, when we're adding or subtracting fractions, we need to have a common denominator. So I'm going to change 1 into 5 over 5 minus 14 over 5 equals b. And therefore, b equals -9 over 5. Okay. So now that I know this, I have my m value, which came from my derivative here, and my b. So I know that my equation, so therefore the equation of the tangent line is y equals -14 over 5x minus 9 over 5. Okay, so that's how you do one of these questions. Again, it's a long process, but as long as you follow what we did here, you should be okay. Thanks for watching the video. I plan on posting more videos later on this week. Thanks for watching.